The Internet Archive hack is still raging on. Here's the timeline of events: September 28, 2024. Last known data included in the stolen Internet Archive database. This suggests the database was likely stolen around this date. 31 million user records were stolen October 6, 2024. Threat actor shares the Internet Archive's authentication database with Trehunt, the creator of IBM Pound, data breach notification service. October 8, 2024, Internet Archive suffers a DDoS attack, later claimed by the hacktivist group Black Meta. Threat actors inject a JavaScript alert on the archive.org website, announcing the breach and directing users to IBM Pound. October 10, 2024, DDoS attacks resume, taking archive.org into the library.org offline. October 13, 2024, Internet Archive resumes the Wayback Machine in a provisional capacity. October 17, 2024, archive its services are restored. Bruce DeCall, founder and director of the Internet Archive, announces that the Internet Archive is working to bring other services back online. October 20, 2024, threat actors exploit compromised SendDesk API keys, gaining access to over 800,000 support tickets dating back to 2018. Hackers begin responding to SendDesk support tickets, notifying users about the exposed data and criticizing the Internet Archive security practices. October 21, 2024, the day of this recording, Internet Archive begins offering provisional, read-only access to archive.org. Uploading, borrowing, reviewing items, interlibrary loan, and other services remain unavailable. While this is troublesome, we have to realize that much of archive.org's source code is open source and can run elsewhere, and other products that provide the same service. Maybe that's an incentive to a more decentralized web archiving solution. One that I tested and found quite simple to set up with Docker was ArchiveBox, that I'm shown on screen. IBM has just released Granite 3.0, the most advanced family of AI models to date. The announcement was made at their annual Tech Exchange event, and this release has some exciting implications, especially for those interested in AI and enterprise tech. Granite 3.0 comes with a new instruct model, designed specifically for building AI assistants that can handle general instructions across a wide range of domains, with strong focus on business applications. Here are some key features. Responding to general instructions. This model is fine-tuned to understand and follow user commands, making it perfect for task-based workflows. Imagine telling it, schedule a meeting for tomorrow, and boom, it gets it done. AI assistant development. Since it's built for handling instructions, it's great for developing AI assistants that can interact conversationally and actually perform tasks as directed. Multi-domain applicability. Granite 3.0 isn't just for one industry. It's designed to work across multiple sectors, but IBM is particularly targeting the business world with this release. And here is where things get really interesting for the FOSS community. Granite 3.0 is released under the Apache 2.0 license yet. That's right, it's fully open source. This means that developers, startups, and even large enterprises can adopt, modify, and deploy this AI tech without worrying about restrictive licenses. It's also integrated into IBM Watson's platform, so it's going to be super easy to plug into existing setups. And to add to that, IBM has introduced a special line of models called Granite Guardian, which are designed to detect and classify risks or harmful outputs, making AI usage safer and more reliable. Svelte 5 has just gone live. After nearly 18 months of development, the latest version of the Svelte JavaScript framework has officially dropped. So, what makes Svelte different from other popular front-end frameworks like React or Vue? The reactivity part. Unlike React and Vue, which rely on runtime calculations and virtual DOM diffing, Svelte moves a lot of this work to the compile time. In other words, Svelte takes your code and optimizes it before it even hits the browser, producing vanilla JavaScript that directly manipulates the DOM. This unique approach means faster, lighter applications with way less runtime overhead. Svelte updated its reactivity process by adding runes. Previously, in Svelte 4 and earlier, the reactivity was compiler-driven, meaning the compiler tracked changes and updated the DOM as needed. But here's the catch: if you change just one property on a reactive object, the whole object would get re-evaluated. This sometimes led to unnecessary updates, affecting performance. In Svelte 5, runes offer a more refined approach to reactivity. Think of them as signals that make reactivity more precise. Runes allow Svelte to update only the parts of the DOM that are directly affected by a change, which not only improves performance but also results in smaller bundle sizes. And one of the key runes to know is $state. This rune lets you explicitly declare reactive state. When you modify a variable using $state, Svelte's compiler takes care of dependencies and updates only the relevant DOM elements. It's a big improvement in both speed and reliability. Also, Svelte 5 is backwards compatible. There's even a detailed migration guide to make your transition smooth. Svelte is a lesser-known framework with a smaller community, but it's considered one of the simpler ones to learn. This update might interest some of you who are dissatisfied with your current stack. No games releasing their source code today, but I hope something here was interesting. Goodbye.